the assistant AV guy.
All right, we're on track 2. Bill Sempf, pentestingasp.net. After this, got free alcohol, so doesn't start till 6. So don't try to rush him. So no matter if you get out early or not.
Yeah. So I'm going to talk until 5:59.
You go longer than that, but
You need to talk into the mic for the recording.
What do you want?
You need to talk into the mic for the recording.
If that microphone cannot hear me,
Okay.
I will be amazed as loud as I speak. I'm not gentle voiced like you.
What?
Yeah, very good, yeah. I have been talking all day, so my voice is starting to get shot. So probably like half of you maybe already know who I am, but I'm going to go through this anyway. I'm Bill Sempf. There's something making funny noises in the room. I am, in largely, well, not completely, but mostly this order, a husband and father. Normally my family's here, but they're not today. An author. I've been writing tech books for Wiley and Rox before them, when Rox was still a company, since 1999. And I'm a serial author, I have to admit. I'm a software composer. I am not a security professional. I've never pretended to be a security professional, and I will not pretend to be a security professional in the near future. I am actually what you would normally call in most businesses a software architect, but I absolutely despise that term because it means jack shit. I am not an engineer. I am the kind of person that takes the business requirements and crafts some kind of solution out of them and then figures out how to implement it technically using the given tools. The project I'm on currently is at Intel. Intel, they have actual engineers who do things like figure out why this electron's going this way instead of that way. That's an engineer. I am not an engineer. I'm a software composer. I got the term software composer from an awesome book. Everyone in here should read it. It's a children's book about software engineering. It's called Lorem Ipsum. It's only about 147 pages long. The guy who wrote it is awesome. And you will learn, even if you have a CIS degree, you will learn more reading this book than you learned in 4 years of college, or 8 in my case. I am a home brewer. I am a lockpicker. Some of you may have been in my earlier talk. Well, it was supposed to be kind of a group talk, but I sort of took over. About lockpicking, and was also hanging out in the village earlier. I am a ninja. Please don't take me to a chair. And I'm also something of an insurrectionist in the application development community. In the security community, I would probably not be considered insurrectionist because you guys are used to saying things that people don't want to hear. In the app dev community, that's considered a very, very naughty thing to do. And I do it almost every single day. I was told once that my charter on a project was to make sure I made the project manager cry at least once a day every day. And I succeeded. Yes. I realized that and part of the reason why many people in the InfoSec community have something of a chip on their shoulder is because you're required to make people cry once a day every day. And so that's not so much of a big thing to you, but it is where I come from. The reason why that introduction was a little bit more slanted towards dev was because this talk, Pentesting.net, is actually a talk developed and designed to give to developers about security. That was the point. And really, what I'm going to do is show you, because one thing that I've learned is that a whole bunch of the information security industry largely comes from either people who recently, anyway, have been brought up in the security channel of education, people who started in InfoSec and have never really learned either IT Pro or App Dev, or people who came from the IT Pro side. Most information security people are not actually from the development side. In fact, none of them are. I've learned a tremendous amount about the web developer and in teaching them security. You will learn from me 2 things. One, what matters to web developers from the code perspective and why they do the really stupid ass things they do in their web development. And 2, maybe how to speak to them in their language about the mistakes they're making and how to remediate them. Those are the 2 goals I hope to get out of this talk. I've tweaked it a little bit for the InfoSec crowd, but largely it's pretty much the same talk that I give to devs. The only difference is that I'm not going to teach you all how to use Backtrack because I figure most of you probably already know. And if you don't, I'm probably not the right person to teach you because I barely know how to use it. So we're going to talk a little bit about how to use the tools at the end, but I'm not going to bring up a demo and stuff. So that will get you to your beer slightly faster. So hurrah for that. So I gave this talk in a 15-minute lightning talk version to the the .NET developers group in Columbus, Ohio. It was a crowd of about 100 people, and there were 6 speakers, and we each had 15 minutes, and at the end, we voted on the winner, and the winner got the speaker's gift for the thing. It's a fun little game. It actually really is. You get to try out a new talk, you get new speakers in who are afraid to give a full hour talk and stuff. It's a good deal. But I gave this talk to them, and by the end of it, they all looked like this, except they weren't quite so nicely dressed. And I asked them, I'm taking out my stuff, next speaker setting up, I was like, all right guys, how many of you genuinely learned something new today that you didn't know before? Not just, got reminded, but genuinely learned something new. Every single hand went up. And I went, oh, okay, put your hands down. How many people had never heard any of this before and are going to cry yourself to sleep tonight? And fully half of them raised their hands. I'm thinking, man, I got a lot of work to do. So I have since given this talk 20 times to application development groups. And I would, in all honesty, I assume I have at least a couple of guys who are fairly good in app dev security in the crowd. Feel free to give me your feedback. My contact information is at the end. So my goal is to make sure that what happened to these companies and their applications don't happen to your applications in your companies. All of these companies at one point or another were attacked, at least partially, through a flaw in application engineering. Not a configuration flaw, not a server flaw, not social engineering flaw, but actually a development error in their internal applications. And I'm going to run into these spots where I'm going to tell you stuff you already know occasionally, so bear with me a little bit. But today, most application developers believe that their apps will only be attacked by some black hoodie wearing guy smoking Marlboros in a basement in Russia. That's who attacks web applications. They don't understand that all of these applications are now scripted. And in the botnets, that's what the botnets are doing, is looking for other things to attack, to attach back to the botnet, report back to command and control, and have somebody go through, sort through the data, and then add that machine to the botnet to further attack more machines. This is all automated. So we get these developers who are professional web people, and they are writing web code for Nationwide Insurance, and they go home in the evening and write the website for their church's volleyball team or whatever, and hang it up on some local ISP, and they don't understand that the security testing that happens at Nationwide is just as important for their app in a way, because maybe the end result isn't as valuable, but their app is just as likely to be attacked, because we're dealing with automated attackers here, not some guy who's after some piece of information. Now, do those guys who are after some piece of information still exist? Absolutely. But they're 1/10 of 1% of the threat from an app dev's perspective, as the botnets are. Those automated tests are much more likely to slam us and make us look bad. So that is the goal of this. We are treating the 80% case here. So what we're going to talk about is what a group called the Open Web Application Security Project has done to isolate the 80% case in web applications and how it specifically relates to ASP.NET MVC code. And where I'm going to, what I'm going to focus on is what the threat is, which admittedly many of you will probably know most of them, how it applies to the Microsoft stack, which some of you may or may not know, and then what remediations are available in the ASP.NET world, which I'm thinking maybe most of you won't know. And that information should be something that you should be able to take back with you and you might find interesting of your own accord. And then I'm going to talk a little bit at the end about the tools I use to do testing and the way I practice, which might be of interest to some of you as well. So, obviously, in this crowd, I don't need to tell you what injection is, but I'm going to anyway. Injection is where you take some piece of information that is deemed, take some field that is deemed appropriate for some type of information and instead use it to pass commands directly to a back-end system through a front-end system. From an app dev's perspective, that's what injection is. I have a field on a form. I need to make sure the attacker can't type a SQL command, an LDAP command, a PowerShell command in that field and pass it back and have it run on my application. That is injection from the perspective of the application developer. Now, of course, naming your son one way or another is I don't know. That's a discussion for another day. Did you hear one of the premier app dev people in the world, literally, Troy Hunt, who knows more about ASP.NET security than probably anybody in the world except for, what's his name at Microsoft. recently had a son and said, and yes, by the way, we did name him tip pred dash dash drop user table, the user tables, da 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 da. It's like, yeah, okay, there we go. So this XKCD takes over the world. You can even be creative when it comes to injection and go after fun things like the speed cameras and such. But these things are outside the scope of what most web application developers look like. What most web application developers look like is this. Now, the last time I spoke at a B-Sides, I spoke on federated identity. And I put code on the screen, and the whole crowd went, oh. Now, I'm assuming since I actually put ASP.NET in the title of this talk, that everybody assumed there would be code on the screen, and that's why nobody groaned. Either that or you're all dead, or maybe the poison gas has got in. So, this is the kind of thing that lots and lots of developers write to just get that quick form up just for temporary until we can get it real good later, because we're gonna make it better in version 2, but right now we'll do this real quick, okay? And this is where SQL injection comes from. Some of you may not have seen this, but this is C# code. And basically what I've done is I've written a method called getByAddress that accepts an email string. So I can call this method from my web form. All right, and some magic happens on the server, either a HTTP post or a jQuery post. Well, it's going to be HTTP post no matter what, but it could be a jQuery or via the form submission built into the browser. It passes back, and my server is going to parse this method. Okay, this is going to be compiled code. It's a binary on the server, but what it's going to do is it's going to construct a string and send it back to my SQL server. Right? That's what it's going to do. I've got my little do query method here, which is somewhere off there. It's got the magic to call SQL Server, and I'm basically building a SQL string and I'm going to pass it in. So what happens if I have this wonderful field here and I type this into it? All right, because what's our query do? Our query is supposed to get an email address by a name, right? Well, I type in some email address and just put it. You actually wouldn't even have to do that. You can just put the tick mark and the or and then the constraints in there. This is the SQL that gets generated by my function. Okay, and needless to say, this is what's been injected. So that's where the term injection comes from. For anybody who wasn't familiar with it, this is a 100% legitimate thing to do. It's kind of stupid, but it's for right, for simplicity's sake. And then I have managed to inject this. How did I do that? Because I know how SQL Server runs, and I can guess what the developer did. So that's what I did. So this is my results. Instead of seeing one user, I see every user in your database. So, what do we do? Oh, yeah. So what do we do? This is actually, this slide's awesome that it's here right now. The answer in today's development is often, oh, don't worry, we're using an ORM. An ORM is an object relational mapper. And what it does is it relates database tables to objects in code so that you can code against the database very easily without having to deal with any of the trauma of understanding how SQL Server works. Okay, it does it automatically. There are two very popular ones. An open source one called nhibernate, which is awesome. It's based on Hibernate in the Java world. And then there is Microsoft's version, which is the Entity Framework, currently in version 4, 5 will be released real soon, which is also awesome, but kind of requires Microsoft's 4-page tools to use. So it depends on which way you're going. So because everything is happening in an automated fashion, you don't often see the commands, you'd see those SQL strings be constructed. But both of those tools actually have a facility where you can still pass a query in. It doesn't look like SQL when you're typing it, and you might not even notice that you're passing a string in that can be injected. But if this, oops, sorry about that. If this string, in Hibernate anyway, there's something very similar for the Entity Framework, but I don't remember off the top of my head what it is. It might actually still be create SQL query, actually, now that I think about it. But if that is in there, then somewhere in the code, your developer is making an injectable point. Because once again, what we're doing is we're building that SQL string on top of it. So the real solution is to always use a parameterized query. And that doesn't make people happy because the developers all love their ORMs, and ORMs pass SQL strings back and forth. They just control it so tightly that there's no chance really for injection. But the only way to actually write a secure database application or LDAP application or application that front ends something on the server like PowerShell that's running to do functional work is to build some kind of parameterized query system where you have to fill in a value with a very specific, fill in a field with a very specific value, and then it gets blocked off at every point, so that there is no opportunity to inject information into the database. So that is the one and only solution to the problem, and it's not a very happy thing, because the first time an application gets injected via SQL injection and it's running on an ORM, and then your manager says to you, how can we make this injection proof? You have to say, rewrite the whole database layer. And I'll tell you what, that don't make anybody happy, but it's still the answer. Crosssite scripting is, I'm sure, something else. It's not obscure at all. You're all probably very familiar with it and its output. In fact, it is so well known that there is a website called xssed.com that lists every known site that has a cross-site scripting vulnerability, how long it's been in there, and some other fields, I forget. How many people have noticed it, and I don't know, and a mirror of the code so that you can look at it later. And it's amazing the stuff that's been on there. I mean, Microsoft shows up on it like 5 or 6 times a day because they're always pushing out new content and they leave cross-site scripting vulnerabilities in their code. And I'll show you how Microsoft does it in a minute. It's really interesting. Oh, I've got the list here. If it's a famous site, if it's a government site, what the status is, fixed or unfixed. Oh, and then PageRank by Alexa too, isn't it? Cross-site scripting is, for those of you who don't know, basically a way to, it's very similar to injection. Actually, it is an injection. In all honesty, there's just no back-end system. You're injecting the front-end system. You're putting content in the code that makes what the user sees different instead of what the back-end system sees different, right? So I'm going to pass something in that is going to make what the user sees different from what the original application developer intended. For instance, this is votehillary.org, their forums, or not forums, their blog. And you can make a comment on their blog. And instead of using a well-established commenting system, they wrote their own, and they left it cross-site scriptable. So what somebody did is they wrote a simple cross-site scripting piece that would make an iframe that filled the entire screen and pull up Barack Obama's stuff. So if you went to Hillary Clinton's site, that's what you would see if you went to see that blog post. That is a very simple example of cross-site scripting. There's all kinds of things you can do that revolve around user trust. Like for instance, redirect users to badsite.com. You know what I mean? So you have a content management system in your company. Somebody finds a cross-site scripting flaw. They start posting information up to that site and redirecting users, or using a like Flash or JPEG vulnerability to, or PDF vulnerability to get into their local machines. That's what cross-site scripting is used for from the security perspective. So what does it look like? Well, what it looks like is really very similar to injection, except you're writing unvalidated user input back to the screen. Instead of parameterizing going back to the SQL server, you're failing to encode going back to the screen. So I've got some kind of data table called posts, and I'm getting the rows of posts, right? And what I'm doing is I'm just writing the output to the screen, right? Write the column name out there, write some text out there. And I'm just spitting all of this out down here, just spitting it out onto the screen exactly as it was in the database. So you can check the data coming in, you can check the data going out, but you have to check the data, right? Preferably you check the data both places, but how do you check the data? That's the problem we've been dealing with. How many of you have remembered the early days of the internet when you couldn't type a bracket? Yeah, you couldn't type a bracket in any text field because everyone was so afraid of cross-site scripting, they were afraid you were going to type a script tag, so they stopped brackets. You couldn't type a bracket anywhere. You couldn't type a tick mark because of SQL injection. So you couldn't say its properly. You could only say its. That's the thing we're dealing with. So, and this is the kind of stuff that's going into there. This kind of code, which is 100% legitimate HTML, but it would cause an alert to show up on the screen instead of the image tag. And actually, this one will get past most of those cross-site scripting filters, which is what we're here to talk about. The solution. So the solution is this. In the Microsoft space, there is a XSS filter built into Ask.net, both Webforms and MVC, okay? However, there's two problems with it, and we will deal with the first one in a couple slides. The second problem is, sorry, but you'll see in a minute. The second problem is that the attackers keep coming up with more sophisticated cross-site scripting vulnerabilities that they can exploit. Better ways to encode, different ways to take advantage of flaws in the browser that are perfectly legitimate HTML, but cause the browser to behave in unexpected ways. So you can't, with all the problems you have, you certainly do not need to be keeping up to date on that. Strangely enough, the leader in this is Microsoft. The cross-site scripting library they put into Ask.net was so good for so long that finally Rasinovich, this guy's name I couldn't remember, went to the powers that be, hopefully it was Scott Guthrie, but one of those guys, and said, listen, we can't update Ask.net fast enough to keep this library updated. We have to open source it so that people can use it. And that's exactly what they did. They took the cross-site scripting library out of Ask.net and put it up on Codeplex, wpl.codeplex.com. So you can actually, and they push every 3 months, or they used to, I assume they still do. They pushed every 3 months, and you can go get the latest one and keep your applications up to date. And it actually is well understood by the app dev specialists in the industry to be the best cross-site scripting library out there, really for any platform, and you can use it for any platform if you're using a compiled version. Certainly for Ask.net. So there's your solution in a nutshell. Problem created by Microsoft, problem solved by Microsoft. You don't get to hear that very often. So authentication and session management is, now we're going to start to get a little bit more obscure problems you run into this, but this is actually something that InfoSec people run into a lot. So this is anything related to functions that allow attackers to compromise a password, a key, a session token, anything that allows them to assume another user's identity without actually bypassing a security measure. So the easiest example of that is doing things like writing an application that doesn't check the user's password. Not that anybody would ever do that. But there are more subtle examples of that. Like, for instance, Firesheep. How many people know what Firesheep, or remember Firesheep when it was a problem? All right, well, for the 3 people in the audience who don't know, real quick, for 42 months, Facebook passed their session authentication variable. So the value that kept your session state between page loads, passed it in the clear and never checked it against any mitigating value on either side of the equation for 42 months. So if you were sitting on an open wireless switch, you could pick up their session identifier and become them. And it was so prevalent that somebody actually wrote a Firefox add-on called Firesheep that you could put on your Firefox, and it would scan, watch the traffic, the wireless traffic, if you had whatever installed, the wireless scanner, the network scanner installed. It would scan the traffic around you and pick up session IDs and just list the people in the sidebar, and you could just click on it, and the browser would reload, and you would be them. That's how blatant of an error it was, and yet it took them 42 months to fix it. Why? Well, it's a relatively sophisticated problem. And surprisingly enough, even though it's a simple exploit, fixing it is not so easy all the time. The problem comes in how your application implements session state. And now, once again, session state is how the server remembers the user from page load to page load. Because remember, when you make a request to a web server, it comes back, it forgets all about you. It doesn't remember that you were there. You have to remind it the next time you come back. And what you do is you pass some kind of value, some special secret sauce that goes back and forth. If somebody else picks that value up off the network stream, they can be you. So you have to use some other form of mitigating factor to make sure that doesn't happen. If you're using some kind of in-process session, and you set this cookieless value to true, there's nothing on the machine of the person that shows that that machine was where the state was. And this is a very common way to implement session state in Ask.net. So this problem was prevalent in Ask.net webform sites all through 1.0 and 1.1 and 2.0. You can still find hundreds of websites out there on the web today that have this exact problem. So what do you do about it? Well, there's really, the problem is there aren't very many things you can do about it. If you've implemented some kind of cookieless protocol and you're just sending a token back and forth either in the HTML or the query string, then somebody can pick it up. So you can go to SSL, so nobody can see your traffic. You can never let your application get into the public, which we all know how well that works. Or you can do things like check the MAC address of the machine, which is doable. If you're curious about this, I don't know how curious this crowd necessarily would be, but there's an awesome article in MSDN Magazine by Jeff Pricey about this. Really a very effective way to check the MAC address. Now I realize MAC address can be spoofed, and you've probably all got 9 applications on your machine running right this second that could do it, but the botnets usually don't. So it's really a pretty effective way to do it. Now a dedicated attacker could find the address of a machine of a person who should be using the application and use that MAC address, but it would be extremely difficult, you gotta admit. So it's really a pretty effective way to pick up the information.
Does that check the MAC address or the IP address? Looks like it's doing an HMAC on the IP address.
Can you repeat the question?
Yes. He asked if it's checking the IP address or the MAC address. Maybe I stole the wrong code from the article.
Oh, that's doing a hashed message authentication using the IP address.
You're right, it is. I stole the wrong piece of code from the article. And I've given this talk how many times and nobody's noticed that except for you. You said you were going to sit here and heckle me.
Okay.
All right. So the article does cover picking up that information from the server variables, but that's neither here nor there. There is also, and we're here to suppose, I mean, these top 10 pieces are talked about from the are all from OWASP, right? OWASP has a lot of free tools available. Probably most of you know about them from the scanning perspective, but really they have a lot of good development tools too. One of the premier projects on this is API, the Enterprise Security Application Programming Interface. And then there's a whole suite of tools. There's one in Java, there's one in Python, there's one in .NET, there's one in PHP. I think they even have some of it in Perl. That allows you to mitigate some of these security flaws, and one of them is session management. So there is a tool in there. I haven't dug into it to figure out how it works, but I've been told it works awesomely. And I assume it has to do with probably implementing some kind of cookie-based token, even in a cookieless environment. So that would be my guess, but I don't know. We'll have to dig into it one day and take a look. Direct object reference is another really unique error that's very specific to application development in most cases, but not all cases. For instance, here's a good example out of the WebGo, which is something we'll talk about at the end. This is Burp, and this is a piece of code that's showing a direct reference to the WinInit file from a web application. So somebody, this is Goat, so it's insecure on purpose in order to show this. But I can remember back in the days of early web development when we would just open up files on machines and provide direct pointers to them in order to get something done. Needless to say, that's obviously a bad thing. Today's day and age, we wouldn't make those kind of mistakes, hopefully, but it's still something to look for. But a more common direct object reference relates to databasing. Now, when I say direct object reference, what I mean is something that's exposed to the public, exposed to the user, that directly references something internal to my system that the user shouldn't know about. Okay? So this is a great example pulled right off Facebook. I love to pick on Facebook, sorry. But this is a great example pulled right off Facebook. In Facebook, if you have a Facebook account, you can be found on their public person feed using the Open Graph. Everybody's on there, your name, at least your name, your Facebook ID, maybe your hometown. I don't remember exactly what the base fields are. But your Facebook ID is in there, the actual between 10 and 18-digit number they use to represent all their users, okay? That's an important fact there, 10 to 18-digit number. So here's me, with my account, and I've said my email is public, so it shows up in the public stream, because you do have to have permission to access anything that has been marked private. But your name and your ID are always available on that service. But I've said, yeah, my Twitter account's out there, my email account's out there, and you can see that stuff. So if this is a JSON block. It's a way of implementing streaming a database. What's the word I want? Never mind. Making a database into a string that can be handed over a web system.
Serialization.
Serialization. Thank you. A way to serialize a database call. And this is me. And the problem with this is the ID. That's where the direct object reference is. So I have given the attacker a direct look into a very specific piece of my database that they can use by iterating the number. That's not a good thing. Now, before you think, well, okay, Bill, but it's just the next person. It's the stuff they mark private or stuff they mark public anyway. So does anybody really care? Well, yeah. I think if you walked up to most people on the street and said, "Hey, did you know that anybody who wants to could just go download every single user in Facebook's database, at least their name and their ID?" I think that some people would be upset by that. But more importantly, is people fail to notice that numbers and text strings can be iterated. And if you put them in places like the URL string or in the HTML, that people can pick it up and iterate through it in their own systems. Chase was just banned. Fortunately, I'm a consultant, so I can always bring up people's names, unless I work for them. But neither here nor there. Chase just got binged because they had an application sitting out on the web that literally had the account number in the URL string, and you could just iterate it by one and log in as that person. So what do you say? So how do we mitigate this? Well, the easiest way to mitigate it is by using something like a GUID, some non-repeatable value that if the iteration, the possibility that iterating the last number in it is going to bring up the next value or any other value in the database is so small it's not even worth attacking. But an even better way to do it is, once again, the SES API, they have something called reference map that will actually make a temporary table that links the entity that the public sees and the entity in the database, and then destroy it after the user's done with it. So, is that a lot of extra work? Yes. If you're talking about bank accounts, is that probably a good idea? Oh my God, yes. Okay, so there we go. So cross-site request forgery is an awesome, awesome thing. And this is actually a big win. I've spoken at a lot of security conferences because I've kind of gotten a rep because of the Lockpicking piece. But for the first time ever that I've been to one, I got an actual pen tester security pro to speak at a developers conference, and he spoke about CSRF. And we had a lot of O-faces in that audience too. There was a whole bunch of devs going. I mean, he literally had he spun up a PHP content management system, and then CSRF the administrator account, and then uploaded a shell and messed around with the system. It was pretty impressive. For an hour talk, I mean, it was pretty cool. Anyway, you probably all largely know what CSRF is for. It's used to borrow an identity, just very much like authentication management, except instead of taking over a user's privilege by watching the feed between the server and the browser, you're actually going to exploit a very common flaw in today's browsers, which is having multiple tabs logged into multiple systems and getting access to the credentials that are already in the browser's current memory because there's a tab sitting someplace that's active. So what way this is commonly exploited in ASP.NET MVC is that there's nothing stopping somebody from hosting the HTML of an MVC site on their own browser. So they can do things like convince via a phishing campaign a user to click on a link in the email that will take the user to a site that looks just like their company's intranet, but is actually hosted on badsite.com and log in, something like that. Or go to some other site that is totally unrelated, and then you can pick up the credentials from the browser cache, those kinds of things.
So just cross-site scripting.
Well, yeah, that's true too. But the specifically related to this though, you can fix it. See, you're just gonna sit and you're taking notes on things. Oh, jeez, you're gonna get me bad. You're gonna get me bad on this. So how do you fix this? How do you fix the ability for some site to be able to post on another user's behalf? That's really the kind of question. No matter how you're going about it, whether the attack's via XSS or via a phishing email or via using data in the browser cache. How do you fix it on the server side? You fix it by the easiest way. The way we used to do it is by checking the referrer. So making sure that the previous site that the user was at is the site that we expect it to be, which would be us, or something similar, very similar to us. That doesn't always work today because we don't have multi-step login processes, and we have these big, broad intranets that log in from all kinds of different places. Also, the referrer can be, once again, spoofed. So that's not always the best thing for a targeted attack. However, the best way is, believe it or not, to do something that most developers today really dislike, which is using view state in ASP.NET Webforms. See, Webforms tried to make the development world easier for the developers by hiding a bunch of implementation details in this huge encrypted block in the middle of the web page that was in a hidden form variable called the view state. And it would get parsed in the server every single time. While it was horribly ugly, slowed down a whole bunch of websites, and was terribly abused by developers, it did completely solve the problem of cross-site request forgery because it guaranteed that the same transmission was being made back and forth every single time. MVC, however, fails to have that implementation because they have no view state. They have no state at all. If you want to manage state, you have to do it yourself. But there is actually a way you can do it. You can include something called the anti-forgery token, which is built right into MVC. It's always been there. I have no idea why it isn't on every single site. And then check it in the controller all the way back. That's all you have to do. It's the easiest mitigation in the world. It should be just built into the template. It's not. I don't know why. And it would solve this problem, which is really becoming much, much more popular as web applications become more complex. I don't need to tell anybody in this room about misconfiguration, but I do want to bring it up for one particular reason, and that's this. This is the cause of 90% of cross-site scripting attacks on Ask.net websites, turning off the cross-site scripting filter. Because in fuzz testing their own applications, the user types something, or the developer types something that pisses off the cross-site scripting filter, and it comes back with the yellow screen of death. And there's this, I really need to put it in my quotes, there's this, there's an error message that always comes back. Well, we're sorry, but the input that's been detected may cause cross-site scripting under some circumstances, so it's not permitted at this time, or something like that. If you search for the string on Google, the first 42 results, as of a year ago, all say, oh, just turn off your cross-site scripting filter, it'll go away. So that's what everybody does. That, my friends, is a misconfiguration. And it needs to be checked for. There's also other misconfigurations that you all are much more familiar with, like right-clicking on a directory and saying, I just like to add everyone to the admin, or everyone to the read-write control group, which I know I've done 100 times back in the day before I knew that that was really an awful idea. Keep in mind, I've been developing web apps since like HTML had 20 tags in it, so it's not quite as bad as it sounds. So that's misconfiguration. That's, like I said, this is not something you guys are generally familiar with. So insecure cryptography. So I do not want to get into a talk about cryptography here. Probably many of you are very familiar with it. But I think we all admit that there's one thing you never do cryptographically, and that's try to write your own cryptography. Don't do it, okay? It is a horrible idea. Cryptographers are much smarter than all of us. I knew one at OSU, terrifying people. Don't write your own. Also, however, keep up to date. I just did a code review on a single sign-on system that used MD5 with no salt. So, but it was 10 years old, and it looked like it was 10 years old. And 10 years ago, MD5 was fine. Today, it's not. So, don't use your own cryptography. Keep up to speed, you know, and we'll all be okay. But there are some problems, and I don't want to talk about public key infrastructure. Probably everybody in the room could explain it better than I could anyway. But I think there is one thing we all agree with. If you lose that, you're screwed. Fortunately, that never happens to anybody, so we don't have to worry about it. Failure to restrict URL access is a really unique problem, and it's tough to explain to people who write web apps every day, so I'm going to give it a try. So, when you log in, you're given a role in most web applications. Oh, this person's an administrator, this person's a manager, this person's a clerical, this person's just a rote user, or maybe you're given a set of claims that this person is in this department, this person has this pay grade, this person has this birth date, and then because of that you're given certain rights, right? So a lot of places check that in order to render the UI, and then never check it again. So let's see if I can explain this. So here is the navigation of my super simple web page, okay? And I'm checking to see, hey, if this person, why am I pointing? If this person is in the administrator role, then show them this link to the restricted page. Now, if they could never, ever, 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 ever guess the name of this controller, that would be awesome. But if somebody like saves a link to it or sends it in an email, or somebody has, oh, I don't know, a list of 10,000 potential hidden web web addresses that you can sort through every single time you attack a site, not that any of you have that, then maybe that's a bad idea unless you also check the page they're going to make sure that they're still an administrator and that they had access to get there, not just access to see the navigation. Does that make sense? It's really very easy to do it in the controller of an MVC application, and you should make sure that it's happening. And this requires, I mean, and this is a software architect talking to his InfoSec staff here, or InfoSec people in his organization. That's a very hard conversation to have with your developer, because the navigation scheme is normally something that's drawn up at the very beginning of an application, and at the stage you see the application, it's really hard to change. And I almost guarantee you it needs to be changed on almost every app that you're responsible for, from a security perspective. It's not something that's done right very often at all. I don't think I've ever actually seen one done properly all the way through, ever, in 20 years. And I know I've written hundreds that are bad. So it's kind of a big deal. In intranet apps, it's not that big of a deal, but if you're writing apps that like allow people to modify their accounts on the outside and they get levels based on what they can do, it's a big deal. So take it into consideration. Not using SSL is kind of a simplification of one of the OWASP top 10. But I think we all agree at this stage of the game that every single call over the internet should be made over SSL under any circumstances whatsoever. If we don't all agree on that, we do now, because there's no reason. The only excuse for not using SSL before is that it was expensive and slow, and now it's neither. So, I mean, every single call that's made back and forth should be done under SSL or TLS. I have a, oh yeah, so real quick story, real quick, because I'm running out of time. I was asked to give a lock sport presentation at a lock manufacturers convention. It's put on by a company called YankeeSecurity.org. And I don't know if you can see this, but it's a GoDaddy secure site, or VeriSign secure site. I can't read it. It's one of those. And put in MasterCard Visa number, and I don't know if you can't. It's kind of blurred out on this monitor for some reason, but up here it's very clearly just says HTTP. There's no lock. There's no nothing. So yes.
Well, that's not good behavior. It still could be secure if the form posts are to be secure.
Yes, that's a very, very good point. It wasn't, but yes, that's very true.
But then you're open for spoofing.
Yeah, that's right. Yeah, there's still the push of my data back to the server could be secure if the form post is secure. That's true, but it wasn't. Not that I posted. I actually looked. I should put the code up there. That's actually a really good idea. So I go on here and tell people how to set up IIS for SSL, but you guys don't care about that. You largely all know how to do that. So use it. Use SSL. Tell your dev team to use SSL. No excuses anymore. Also, use SSL in your middleware. If you have a service layer in your organization, you're exposing things to partners, every transaction should be covered by SSL. There is absolutely no excuse for some contractor at the ISP that you're using being able to sit and watch your service traffic. That's stupid today. It's stupid. Don't do it anymore, please. Unvalidated redirects is real similar to URL checking that we talked about before. This is a remarkably common, it's very simplified, but a remarkably common kind of method you find in MVC applications. Oh, well, if this word is passed somewhere in my magic code, then send them to the edit record. If this word is passed somewhere in my magic code, send them to the add record. Otherwise, assume it's URL and send them directly there. That's a really, really bad idea. It mitigates, it blows up trust in the application and allows attackers easy ways to get people to go places they shouldn't get to go. So validate your redirects. Make sure that every URL that your site is sending somebody to is actually a URL you want them to go to every single time. Okay, so that's the top 10. And I did it in 45-ish minutes. That's not too bad. So I'm going to talk real quickly about three things. The first is tools. So what I've been telling people to do in the development community is download Backtrack 5 as an ISO, set it up as a VM, and play. Now, I know you're all interested. You're like, oh, Backtrack 5 is a script hitting tool. Come on. Hey, it's easy, it's free, and a lot of the tools actually work. What's more, almost everything in it is a script. There's almost no magic compiled stuff, though admittedly, InfoSec community is a lot better these days, and there's almost no magic compiled stuff anywhere anymore. But it all can be added to the unit test, integration test, or QA level testing of these apps. So we can automatically test our applications for things like unvalidated redirects and cross-site request forgery. Because the tools that you guys are using every day to do your pen testing or analysis are already doing that. Why shouldn't the developers be doing that, or their QA staff be doing that, or the testing staff be doing that? That's what should be happening. So they can take Backtrack and play with it, learn how to use tools like, simple little dippy things like XSSR, which is the one I usually demo, and then look at it, realize it's just a Python script. Actually, that one's a Perl script, but you get the idea. No, that one's a Python script. You can just put it in with the rest of your tests. There's no reason that your build server can't run that test along with all your other unit tests. You configured it to run Cucumber and Ruby. You can configure it to run Python. Just do it. So that's the reason why I demo it that way. And if in all seriousness, I have my contact information up soon. If anybody has any recommendations on what else I should be telling people, please tell me, because I really, one of the reasons I wanted to give this talk to the security community is to get some kind of feedback on it, because I've literally given the talk to like 15 different small groups and at 5 conferences to devs. So feedback welcome, including yours, believe it or not. The other thing I tell people to do is practice. And this is something you might not know. If you're dealing with ASP.NET and you're not as familiar with it as you are with, say, PHP or Java, there is actually a WebGoat for .NET now. Jerry Hoff has finished it. It's 1.0. It's downloadable from the OWASP webpage. You can go on there and search for webgoat.net or go to my GitHub page, and I will have it forked, or Joe's GitHub page, he will have it forked. And then download it and play with it. There is also a VM that I haven't gotten a chance to play with, but apparently there's some virtual machine that has a whole bunch of applications. What these things are is they are applications that are purposefully written to be flawed, to have security vulnerabilities in them. And you can test your tools against it without having to blow up your company's server, which sometimes will get people in trouble. That's the first thing they say is, my company won't let me test the apps like that. Fine, don't. Set up 2 VMs on your machine. Nobody will even have to know. It's true. Well, okay. Yeah, it's a chuckle, all right. So the dev staff doesn't have to know. All right, never mind. I tried. So OWASP has local meetings. We have a meeting in Columbus where Brett Houston, who is a bigwig in Columbus information security scene, does a lot of, not SERPA, what's the term I'm looking for? SCADA stuff. And Jim Manico, who is with White Hat Security and is out of Hawaii, but he's doing a project somewhere, Toledo somewhere. So he asked a couple of people in Columbus if he could talk. He's a bigwig. Brett's a bigwig. 2 big talks in Columbus. If you're anywhere near us, come on down. It'll be all over the internet eventually when we start promoting it, so you'll see it. But I do have a question for the room. Is there a Cleveland OWASP organization that meets with you? Is it awesome? Yay! I have no idea who runs it, but go. They need more people, and they need your support. I'm Bill Sempf. I'm at Sempf on Twitter. You can find me. That's where I hang out. You can find me all the time. If anybody has any questions, I will do my damnedest, but I make the promises. But thank you very much. That's the talk, and you can come talk to me and ask.
We got tickets back here for drinks too at 6.
Woo!
Yeah.
So how drunk do I have to get you to convince you to actually tell me what you really thought?
To a what?
How drunk do I have to get you to have you tell me what you really thought?
I'll tell you what I really thought right now, but hold on a sec.
I know you'll do it sober.
Alright, I hit stop there?
I hit the little red button there.
This one?
Oh, that's right.